Good evening, students. This is Jyoti Shankar for Physics, Kinetic Theory of Gases, 11th Standard Chapter. So, the Naria formulas you have seen in your textbooks. But what we're going to see today is the average kinetic energy of 1 mole of monatomic gas. So, ஒரு monatomic gas எடுத்துக்கலாம் அதோட degree of freedom உங்களுக்கு தெரியும் 3 by 2. So, the average kinetic energy will be 3 by 2 RT. So, this is universal gas constant. இப்போ the average kinetic of mu moles of monatomic gas, it will be 3 by 2 mu times RT. இப்போ universal gas constant we are using அப்படின்னா we need to multiply by the number of moles. Similarly, the same average kinetic energy can be also told as அதையும் வேற மாதிரி என்ன சொல்லலாம் 3 by 2 k times t, that is Boltzmann's constant. In the R universal gas constant, it is 8.314, you know it. The Boltzmann's constant is 1.38 into 10 power minus 23, அது உங்களுக்கு தெரியும். Suppose you want to say for n number of full gas occupy ஆகிருக்கிற சொல்லணும் அப்படின்னா n number of molecules சொல்லணும் அப்படின்னா it is number of molecules into k into t. So this also can be told as 3 by 2 small r into t, which is specific gas constant. So இதில் நீங்கள் ஆவரேஜ் பண்ணி டோட்டல் கேஸ்க்கு சொல்லணும் அப்படின்னா you need to multiply by the mass of the gas in grams. So 3 by 2 m into small r into t. So there are three formulas. 3 by 2 mu times, that is number of moles into universal gas constant. 3 by 2 into number of molecules into Boltzmann's constant. 3 by 2 into mass of the gas in grams into specific gas constant. And one more thing, the root mean square velocity, it will be root of 3 by gamma. That is, you know, gamma, it is Cp by Cv. Yeah. And one more thing, this we remember, the momentum, the change in momentum, it will be minus 2m into Vx. Suppose this is in x-axis, y-axis it is minus 2m into Vy, z-axis it is minus 2m into Vz. And the time between two successive collisions of the gas molecules, அது வந்து the total distance between two gas molecules will be 2L divided by velocity. So the force exerted by molecule on the container walls, இப்போ ஒரு கண்டெய்னரில் we are containing a gas. So what is the force exerted by the molecules? The rate of change of momentum divided by the time taken by the between two successive collisions. So 2mvx divided by 2lvx, அதான் mv square divided by L is a common. ஓகேங்களா? அது இல்லாமல் we want to tell you one more fact clearly. The pressure of the gas will be 1 by 3 small n into small m into v square. That is root mean square earlier and the v. So now what is n? We say it is n is going to be number density அப்படின்னு சொல்கிறோம். But what is number density அப்படின்னா the number of molecules divided by volume. So you have the gas contained in a container. What is the number of molecules contained per meter cube is the number density. So the small n, please do not confuse with the other n's that is used here for the average kinetic energy. So in the 1 by 3 n into m here is going to be mass of one molecule of the gas into the root mean square velocity square. Okay, now what is the number density? Number of molecules per volume. Okay, in the n-um m-um combine ஆச்சுன்னா number of molecules due into the mass of one molecule will give the molecular weight of the gas contained, இல்லையா? So that is 1 by 3 m by v, the root mean square velocity square. So there are two varieties of the formula. Pressure, it is 1 by 3 n m v square or 1 by 3 molecular weight divided per volume into v square. எப்படி வந்துச்சு, you know it, isn't it? So this is one concept.